Okay, welcome everyone to the presentation of the Bachelor curriculum in Artificial Intelligence at Johannes Kepler University. The outline of this short presentation is as follows. First, we will discuss what actually artificial intelligence is. We will go through its definition. We will see that it is a very interdisciplinary subject. We will have a quick look on its impact on society and economy. And then in the second part of this presentation, we will talk about the bachelor's program here at our university, some general information, the study plan, and the qualification profile. So let's start. What is AI? AI refers to the ability of machines to perform cognitive tasks commonly associated with human intelligence. And this includes perception, learning, reasoning, making plans, speech and language, and also taking actions. This is a kind of a standard definition, although there is not a full consensus on how to define it precisely. One very old, from today's perspective, approach to the field of AI was the so-called Turing test. So Alan Turing, one of the fathers and founders of theoretical computer science, in 1950 devised the following thought experiment. You have a wall, and on one side of the wall there is a human, here labeled with C, and on the other side there is either a computer or a human. And both the human and the computer pretends to be a human, and the human, of course, correctly says that he or she is a human. And then by interchanging of text or speech or whatever kind of information, it's the task of the human C to find out whether he is actually interacting with a machine or a person. And this Turing test, in some sense, in many precisely defined tasks, is already achieved by machines. So for instance, I show you here a few pictures. These are paintings, so digital paintings, conceived by machines, and actually at the Art Basel in 2017 these paintings were awarded, and a human jury couldn't distinguish them from professional human paintings. Let us have a quick look at the interdisciplinarity of artificial intelligence. So first of all, AI relates to many other fields of science. It is, strictly speaking, a subfield of computer science. It has strong overlaps with the field of mathematics, but also with biology, the whole field of bioinformatics in that direction, and then, of course, psychology, philosophy, sociology. All these fields somehow have relation with artificial intelligence. And on the other hand, AI itself is composed of many subdisciplines. So, as we already had in the definition, there's the field of perception, there's natural language processing when it comes to speech and language, there's the whole field of neural networks and machine learnings, planning, reasoning and knowledge representation, and when it comes to taking actions, it interacts with the field of robotics. So let us make a quick historical view and find out the interrelationship between the terms artificial intelligence, machine learning, and deep learning, because deep learning is a very dynamic subdiscipline, which also our study program will have a focus on. Artificial intelligence is already an older discipline. It dates back to the 1950s. Arthur Samuel had already IBM PCs playing checkers against each other. The perceptron was invented there. Joseph Weizenbaum had an early kind of chat bot. And so these were early artificial intelligence that stirred some excitement throughout the decades. Then in the 1980s, the subfield of AI, machine learning, began to flourish. The optical character recognition in scanners, spam filters, the whole field of genomics in the 90s, and also the first Google search. These were all machine learning tasks and achievements. And then, in about the last 10 years, the field of deep learning emerged. and led to many breakthroughs and somehow drove the boom of artificial intelligence that we are seeing in the last 5 or 10 years. So all modern image, text, voice, music or video recognition or processing, the autonomous drivings that companies like Tesla and Waymo and many others are pursuing, and also you probably have heard about AlphaGo, that now artificial intelligence can outperform humans in playing Go. These are all achievements of the field of deep learning, which itself is a subdiscipline of machine learning. And what has driven this AI boom? What made it possible that deep learning led to such a revolution? Because the theoretical foundation stayed already back to the 90s, but it was in fact fast computers and enormous data sets that are nicely labeled. And if you have these large data sets and can train neural networks with fast computers, then you have these enormous achievements. And this is what led to the deep learning revolution. We can make a loose comparison. The 20th century was mainly driven by electricity, and the resource of electricity is mainly oil or gas or whatever. And if you now see that artificial intelligence is, so to say, what we want, then there is a resource to it, and the resource is data. Data. We believe that artificial intelligence will be omnipresent. It already pervades commercial applications in an unprecedented manner. It's changing how businesses operate across almost all sectors of industry and economy. So let's have a quick look. You of course know that there is the information technology sector, the speech and image recognition or translation software, so whatever your mobile phone, whether it uses Siri or Google or Alexa or whatever, this is an achievement of AI built in. Then you have the fields of manufacturing and supply chains, where AI can optimize production and delivery processes. There's the whole discipline in medicine and healthcare, where AI allows us to have better diagnosis and evaluations, and also to design new drugs. And in education, publishing, marketing, but also in financial, legal, and tech services, there can be recommender systems based on artificial intelligence. And then, last but not least, of course, the whole transportation business when it comes to self-driving trucks and cars. This is where AI will play a very prominent role. Let us have a quick look at the impact on economy that we can somehow estimate to observe. So here I cite a study of Accenture from a couple of years ago, but you can find similar studies from McKinsey, PricewaterhouseCoopers, or however you look at. And the main message here is that for the next 15 to 20 years, whether or not we adopt AI into our industry and economy leads to a doubling of the growth rate. So for countries like Germany and Austria, there's a predicted growth rate of our gross domestic product of about 1.4% per year if we do not adopt AI into our industry and economy. And if we do that successfully, we can achieve something like 3%. Of course, these are just estimates, but you see the gist here that whether or not nations are able to use this new technology really decides their future and development. So now let us quickly look at what I already mentioned in this deep learning subfield. In deep neural networks, we have multiple hidden layers in an artificial neural network, and there's a gradient descent method used to minimize the error. But what actually you do is you feed in, for instance, lot of pictures into the first layer. The layers are connected with each other, and in the beginning your network is completely randomized and gives a random answer, but with some feedback and with lots of thousands and millions of pictures you begin to train it, and in the end it will be nicely able, for instance, to distinguish between horses, dogs and cats. And once such a network is trained, it can perform very well also on unseen pictures, for instance. But you can do the same not only with pictures, but with text, with maybe some scientific data, with music, and so on. A very modern development in this field are so-called generative adversarial networks, or GANs. And here the trick is that you have two neural networks playing against each other. One is a generator network that tries with some random input to produce a reasonable output, for instance, a picture of a human. And then there is another network, the so-called discriminator, and the task of this network is to simply get a picture generated by the generator and then decide whether this is a real or a fake example. And they play against each other for a large amount of time, so again and again and again, maybe for millions of pictures. And in that procedure, the generator gets better and better in faking images. The discriminator gets better and better in trying to distinguish whether an image is real or fake. And in the end, both networks are really good. And so, for instance, if you look at these 8 pictures here, this is generated by NVIDIA 2 years ago only, and you try to find out what is a real human and what is not, then the answer is none of these people exists. All these 8 faces are generated by a computer algorithm. And this somehow reminds us on Arthur Samuel's task or achievement in the 1950s, where he had 2 IBM machines playing checkers against each other, learning and getting better and better. So just to show some examples here, we can use these GANs to learn how to switch from zebras to horses and back, or to change pictures from winter to summer, or from paintings to photos, or even to change the style of a photograph. This is all an example of what GANs can do. There's also the whole field of these deep fake videos, where you can have an actor playing some, citing some text, and then you put the face on some American president or Russian president. You can find such videos on YouTube. Another subfield which is extremely important and dynamic in the last years is the field of reinforcement learning. This is where an agent takes actions in an environment trying to maximize the reward. It's related to the field of optimal control theory. So for instance, a drone, you would like it to not crash. You can see it on the top right picture. The drone is thrown in the air and it tries to stabilize itself. And in the game of Go, the reward is winning the game. And let us quickly dive into this, because it shows the paradigmatic change that really happened in the last 10 years. So if we look at chess, this is a very old game with simple rules. It has a very large game tree complexity, but already in the late 90s, the IBM Deep Blue, which was a brute force program and had the position value hard-coded, a queen is worth that amount of points, rook that, and this is the position value. Already in 1997, Deep Blue could beat the best player at the time, Garry Kasparov, and from that moment on, practically humans had lost. So there was no chance anymore to beat the computer, because, of course, with Moore's laws, they got exponentially better, and we humans, well, the day has only 24 hours, and maybe now the best player, Carlsen, is better than Kasparov was 20 years ago. I don't know that, but sure, he's not exponentially better. Okay, so chess could be solved brute force with standard computers and algorithms. But with Go, it's a bit different. Go is also an extremely old game, dating back 2,500 years. It has its roots in China. It has extremely simple rules, and the game tree complexity is much, much larger. So it's a 360-digit number compared to a 123-digit number. So chess is nothing compared to Go when it comes to complexity. And therefore, today's normal programs reach only medium strength. So if you're a dedicated Go player and you train for some time, you will beat the best standard computers in the world. There's just too many options. Computers can't go through all of them. However, 3 years ago, Google's daughter company DeepMind devised AlphaGo, an algorithm where the position value was valued by a deep neural net and not hard-coded. And with that achievement, it was able to beat Kertier, the best player at the time, Dan 9 player, with 3-0. So it is the achievement of deep reinforcement learning that led to outperforming humans in the game of Go. So where can this go? Of course, we have science fiction literature dating back decades or not even centuries. Will we ever have machines outperforming us in practically all our tasks? This is the so-called topic of artificial general intelligence, or strong AI. So that would be a hypothetical machine that is at least as skillful and flexible as we are. And now it depends on your dystopian or utopian view of the world, on whether you believe that we will have this in 10 years or 100 years or never. We simply do not know. We do not know which type of necessary hardware is needed and what are the structural algorithms that are needed. But just as a teaser, let us look at the development of the peak operations per second in the best supercomputers in the world. So we have here the graph starting in the maybe shortly before Second World War, and then note that the axis is logarithmic. So we have an exponential increase in the computing power. So today, for €1,000, you can buy a GPU with 10 teraflops. And the orange bar up there, this is the estimate of the human brain. This is the estimated brain power we have. It's 10 to the 18 to 10 to the 25 operations per second. And of course, this is a rough estimate, and this is a research field on its own, how the human brain does it and works. But it could be that at some point our computers can reach the kind of necessary hardware power. But as I mentioned, it depends on maybe your worldview on whether you are afraid of having a strong AI or hope for it. I just mention it here as a nice underlying brain teaser maybe. Okay, let us now come to the second part of the talk, namely the bachelor's program here at Johannes Kepler University. In fact, we have a bachelor's and master's program. Both programs started in October 2019, so the program is very new. At the moment, we still do not have any access restriction. Our program is among the first AI programs in Europe and the first program in Austria, of course. We fully teach in English. This is also why this talk here took place in English. Our study was from the very beginning largely available via distance learning. That means that our lecture notes are online, and almost all lectures are recorded and are available as a stream for some weeks or months even. The field of AI, as you saw, is a technical field, so you will learn lots of computer science and mathematics and so on, but we try to also give you a bit a view or a bit the wider scope. So we have a kind of a subject dealing with the topic of AI and society, where we treat sociological and legal questions, for instance. Our bachelor program is 6 semesters. It is fundamentally interdisciplinary. We have main core education in computer science and math, but also the core AI subjects, which I will mention in a minute. And just mentioning, of course, later you can go on with a master's program. This is 4 semesters, 120 ECTS credits, where we have a heavy focus on the field of deep learning, and there you can choose an elective track. 2 tracks are in mechatronics, 1 is more in a mathematics direction, and 1 is in life science. So back to the bachelor's program. It's a Bachelor of Science degree, 6 semesters, 180 credits, fully in English, and it's a full-time program, but due to the distance learning elements we have, it is somewhat compatible with studying next to having a job. You can see that our study plan is focused on several areas. We treat the AI basics and practical work. Then we have this AI and society subject, lots of computer science courses, data science courses, and then core AI subjects like knowledge representation and reasoning, the machine learning and perception subjects. Then, of course, especially in the first 3 semesters, mathematics education. And then, as usual, you have to pick some area of specialization, 3 electives, and the bachelor thesis. This is the timetable or study plan of our curriculum. I will not go through it in full detail. I invite you to visit the website of the AI program. You will see this information and lots of additional information there. So having said that, you can see that this is a combination of mathematics, computer science, data science, some practical work, and then core subjects like natural language processing, machine learning in the supervised and unsupervised direction, reinforcement learning, and so on and so forth. Let's now have a quick look at our qualification profile, which you can of course also find in the curriculum itself, which is online. The task is here, or the goal is to give you a broad and balanced foundational education in mathematics and computer science with specialized training in core AI subjects such as machine learning, data science, knowledge and reasoning representation, and natural language processing. Our students will learn also about the broader ethical implications of AI for the whole society. We focus primarily on systematic problem solving, so we will want to promote your social competencies in teamwork, in practical training, and to allow you to acquire the skills which are relevant for your later careers. And therefore, the aim of the bachelor program is to prepare you either for the subsequent master studies and also for the immediate entry into the job market. So we believe our bachelor's program is designed such that you will have the knowledge to immediately be able to develop AI solutions in many different sectors of the industry and economy, such as the ones I mentioned earlier. With this, I'm coming to the end. I again invite you, so I hope I have stimulated your interest, and I invite you to visit our website at JKU. Just Google JKU Artificial Intelligence. You will come to the website where you will see lots of additional information regarding our program, the curriculum, program details, and so on and so forth. And with this, I thank you very much for your attention, and I hope to see some of you at the campus studying our curriculum. Goodbye.